Creating control classes. this is actually, I quite like this bit. This is kind of fun. What we're trying to do is actually get some code to work. I'm sorry about the kind of don't ever start by apologizing. I'm doing this as a podcast because it's snowing outside. I can see it's chucking it down now, and I couldn't get in and do it for real, and I wanted you all to have this stuff in time to do something with it, and that meant really knocking it together like this, and I hope it kind of works. It's an experiment of sorts anyway, so stick with it. Last week, well, the story so far, if you can remember, is that last time we looked at this, we were thinking in terms of how to arrange the classes for the game club, and so we had this idea that we're keeping information about the game club, which rents copies of video games to members of the club. And the idea is you walk in and say, I'd like to have a new copy of borrow a copy of Halo Reach, please, and they'll look behind the counter and pull one out for you, and you can then borrow that for a given number of days as a member of the club, bring it back, borrow something else, so on and so on. They also have an area in the shop where you can browse for video games. If you're thinking in terms of sort of like any kind of rental shop type configuration, and we identified a need for a whole bunch of classes, and I drew these up on the board. We had to have a class to keep track of a title, which is a particular video game like Halo Reach, for example, and then we have another class which keeps track of a physical copy of that game, because you have this idea of the thing you really want to lend and the more abstract idea of a particular game title. For example, it's possible for the game club to have a title like I don't know, a very old one like Pac-Man, say, but no actual lendable instances. So we have this idea of classes that represent those parts of the system. We also have classes to represent the members of the club. If I join the system, it'll actually keep track of who I am and how many loans I've got. And we also have classes to keep track of reservations, where I can go into the game club and say, I'd like a copy of Halo Reach, and they'll say, sorry Mr. Miles, we haven't got any of those. Do you want to reserve the next one that comes in? And if I say yes, that's the point at which I'm starting to write code now. So the particular scenario we're talking about, and the reason I'm writing the code, is because I want to reserve a copy of a game. And so we haven't got one in stock. We know the game exists. We have got some actually in the system, but at the moment they're being used by other people. You get precisely the same behavior in any library when you walk in and try and borrow a book, and all the books are out on loan. You can reserve one, so the first one that comes back, that's the one you're going to get. So we're going to look at writing the actual behaviors that create this. There are some business rules which we have to pay attention to as well. You'll have gathered these and put them in your activity diagrams, because that's how the good design works. If I try and reserve a copy, I can reserve up to 5 titles. When a title comes back, when someone brings back a physical copy of the game, we have to make sure that we check that somebody has or hasn't reserved that. So if I bring a physical copy of Halo Reach back into the store, the system will have to go, okay, yeah, that's been reserved by another customer, therefore we can't put it back on the shelf. We put it to one side for that customer to pick up. And the other thing, which are the ground rules we have to work with, if several people want a very popular game, the reservations are dealt with in strict order. So that means the first person to reserve the game gets first shot at the first title that comes back. Now, again, I'm trying to ground this really solidly in what happens in real life. So if you've ever borrowed stuff from the library in the university or done anything like that, you'll know how this works. Okay, so we're looking at the reservation process, and we have a fairly strong idea of how this goes. I like to draw activity diagrams and keep them fairly simple. This is for the use case reserve a game, and it looks quite nice. If I take you through it, if you can see my cursor moving around, first thing we do is find the member. If they've reserved more than 5 titles already, or 5 titles or more, we exit the use case, because there's nothing we can do. They can't reserve more than 5. Then we see, okay, Mr. Miles, what title would you like to reserve? I want to reserve Halo Reach, please. Okay, if that title isn't in our game club, if we don't physically have that title to reserve, then that's another exit point, because we can't have something the system knows nothing about. So if I try and reserve an obscure Japanese Dreamcast game from 1998, then the system goes, oh, not got that. So at that point, it's game over, or more game not started, I suppose is a better way of putting it. So that's fine. Alternatively, we do this final use case, activity here, which is create reservation. Now that there's a lot happens in there. I've just put one blob at the moment. What we'll look at in terms of making the code is precisely what happens at that point, pretty much. I think if I was doing it again, I'd probably go back and look at what happens in the system a little bit more with regard to that. But from the point of view of looking at where we are at the moment and capturing business process, the key things you have to capture in activity diagrams are things like we need to have a member. The member can't have more than 5 reservations, otherwise we get bounced, and we can't reserve titles we don't have. Now, things to bear in mind here as well from a design point of view. If we have a behavior where the system needs to automatically buy titles that have been reserved, then maybe we'll have to have some other activities in here to deal with that. But I'm keeping this very simple because I quite like simple. And from the looks of things, reserving games doesn't look too tricky, because the actual use case we're running is very short. Only has 4 blobs and 3 blobs and 1 decision. So what could possibly go wrong? Well, one of the things you find in system design and this kind of stuff and writing the code is the complication that isn't in one place suddenly pops up somewhere else. So we'll find that as we go through. What I did when I was writing the code, I took a look at what I thought I needed to store in a reservation class, and I came up with this stuff. I've got to have the owner of the person, not the owner of the person, sorry, the owner, comma, the person who actually wants to reserve the title. That'll be a member of the club, and the title itself that's been reserved. And so those are the 2 things that we need to have in our reservation class. I need to know who reserved it and what was reserved. Okay, and so when we reserve a copy of the game, then we make an instance of this class, and pow, this keeps track of our reservation. It's kind of like an association class, because it links together the person who's reserved the game and the title they have reserved. So if I reserve Halo Reach, there'll be a link between the Rob Miles customer record, which will be keeping track of my membership information, and the actual game title, Halo Reach. Okay, so we make this when we reserve a game, and that seems simple enough. Now, we're looking at code that people have made, and generally speaking, sensible things are being done, which is nice. But the thing you have to bear in mind at this point in the process is that we're not going to make any particular class in our system, any of the business objects, in charge of creating reservations. We mustn't make the reservation class do this, or at least this is Robert's thinking on it. Opinions may differ, mileage may vary. As far as I'm concerned, I take the actual behavior of creating a reservation, and I'll put it in a separate class I will call a control class, and this will actually do the work. We'll create tests for these because we're not stupid, and we're trying very hard to get all this right. So we'll create unit tests with methods like we do with everything else, but this will actually be a method that does the job. Okay, so this doesn't live inside any of our business objects. They're just there to sit and hold the data and provide some low-level behaviors. This will sit actually in our control part of the system, where we can create unit tests and all kinds of other good things. And my first create title reservation method is really nice and simple. Doesn't do much. It's given a game club, the game club I'm going to be working on, the member of the game club, which is the person who wants to make the reservation, and the title. And those are the 3 things it needs to work. So it makes itself a new reservation for that member and that title, and then it adds that reservation to the game club. And the game club contains a list of reservations so that we know what's been reserved. Okay, this is a little method that lives inside a control class somewhere. I've made it static. A fair amount of the work has been done in advance before we call this, in that to get to the point where we call create title reservation, we have a game club, obviously, we have the member who we've located, and we have a title we want to reserve. So this is basically the behavior in the very last blob of our activity. If we haven't got a member who can reserve anything because they've already got 5, or the title can't be reserved, then we bounce out. So this is effectively the create title reservation method, and I'll call this when I want to make a reservation for a member of a particular title. And that all seems quite sensible and looks like it should work. Okay, so like I said a few minutes ago, if one bit of the code seems a bit simple, complication suddenly pops up somewhere else. And what happens when you start dealing with reservations is that making reservations is really easy. Dealing with them when stuff comes back, that's where it gets tricky. Now this is my activity for returning a loaned item, because now I have to deal with the fact that when something's been reserved, okay, when a physical copy gets brought back into the shop, we have to say, has anybody reserved this? Because if they have, we have to put it to one side so they can come in and pick it up later. And so this is my activity for returning an item that's been borrowed. We go in at the top, we check the copy to see if the actual physical media has been damaged. If it's been damaged, we mark it as broken, and we charge the member a fine. We say, okay, if you break any of our video games, we'll charge you a fine. Okay, then we'll go and look up the title of this physical copy. So the guy will bring in a CD-ROM. We'll look at that and go, okay, this CD-ROM is a copy of Halo Reach. Therefore, I'm going to look it up on the system and find that title. And if that title is reserved, I have to find the oldest title reservation, the most elderly one. I have to say, okay, we're going to put this physical copy aside for that reservation and put that copy on the reserved shelf. Okay, because we can't put it out in the shop because someone else might come and try and borrow it. So if the item's been reserved, we put it on a special shelf behind the shop counter where the normal members can't come and get stuff. If the title hasn't been reserved, we put it back in the shop. Okay, so if you think about how libraries work, if you think about anything which lends stuff out and allows reservations, you'll come up with an activity diagram that looks a bit like this. I'm afraid the entry point has actually got chopped off my graphic, for which I apologize, but you come in here. Is it broken? If it is, we can't rent it again, and we have to effectively find the member. If it's not damaged, if it's okay to lend out again, we find the title, we check to see if it's reserved. If it isn't reserved, we just put it back in the shop. If it is reserved, we find the oldest reservation in the system. We set that copy aside as a reserved physical copy of the disk for that member to pick up, and we put it on a shelf somewhere out of the way. This is how it would work. If you've got any doubts about how it would go, think about what happens in a library, and I think you'll probably be okay. No worries. Okay, so this means that we have to start looking at our class design, because when a copy of a title is returned, we have to have a way of checking to see if there are any reservations for that title. And if there are any, we have to find the oldest one and assign that copy to the reservation. And at the moment, there's no way of doing that. There's no way that title reservation holds information about when it was created. If we go back and look at the class design, we'll find there's nothing in there that says when it was created. Okay, so we need to update the class to provide that information. Now it turns out this is quite easy. C# provides a type called datetime, which is effectively identifies a point in time as a day and a time, and it's a structure which we can use. And so if you look at my title reservation class here, you'll find that suddenly we've now acquired a CreationDate property, and the idea is that this is set when the reservation is created and allows us to basically put reservations in order of when they were made. So wonderful, super, terrific, and we've solved that problem. Ain't we clever? And now in my constructor for the title reservation, I can say, okay, you're giving me the owner, you're giving me the title. I'll set the creation date to now, so I know that it was created at when this method was called. Then I'll put my reservation owner and my title in place. So turns out this is actually quite easy to add, and so now every time I make a reservation, I'll know exactly when it was made. Now this is good stuff. It's actually very useful to be able to know the kind of stuff. I guess I could do this when titles are added and when physical copies are added, so I can know when they were put into the system. And if you've wondered how to do that, here it is. Get the date time, which is now, put it in a date time member of the class, and away you go. Now it's an important point that's going to probably recur this. If I'd taken the trouble to work through the activity diagrams before I started writing code, I would have spotted that I need to know the creation date, because as we can see here highlighted in this rather fetching shade of pink, there's a activity called find oldest title reservation. Now, to do that, I've got to know when it was made. And so this really, I'm hoping, will bring home to you that you've got to test your class design against your activities before you write any code. Absolutely must do that. I'm banging the table and things are falling over. But it is important, because if I'd spotted that little piece of detail there, I would have gone back and got my class design right first time. As it is, I've dived in and fixed it and put in a bit more detail that I need to make it go. Okay, so that solved that problem. Woo, that was easy. Keep moving forward. Now, here's another little issue that I'll pick up from my activities. When I bring a copy back to the shop, we have to find out if there are any reservations for that particular game. Does anybody want a copy of Halo Reach? If the answer is no, it goes back on the shelf. If the answer is yes, then I find out who wants that copy, mark it as reserved for them, and move forward. Okay, so I need to have something which will tell me, hey, have you got any reservations for this title? And I've done some thinking about this from a design point of view, and this is how Robert would do it, which is not necessarily the best way, but works for me. I think the Game Club should do this. So a Game Club should be able to tell us the list of all the reservations for a particular title. And to do that, well, I can write a little method. Here's the one that works for me. This method returns a list of title reservations, and it's called getReservations for title. I give it the title I want to find out the reservations for, and it then builds the result, which is a brand new empty list, and then it works through all the reservations in my Game Club, and if the title equals the one I'm looking for, I add that reservation to the list. Now, this is something which you shouldn't be too scared of doing. Okay, I'm returning a collection of stuff. Okay, I'm returning a list that contains a whole bunch of references. That's fine. It's the best way to do it. Make the list initially empty, add things to it when you find them, and return the list. So that means that I can now, any title in my system, I can actually ask it, have you got any reservations for this? If there aren't any, the list comes back empty. In other words, I get a list back with no elements in it, and I can use that fact to say, okay, no reservations, lob it back on the shelf. Anybody can come in and borrow that one, no worries. Okay, so this is how I would get my Game Club class to do the work for me, because it's got the reservations in there. It can provide this information. There comes that important point again. If I'd taken the trouble to work through the activity diagrams, I would know I'd need to do that. Okay, so stupid again, because I've had to add this behavior during the implementation. I've had to go back to my Game Club class and drop that method in. Now, it's not a big problem for me, because I'm sort of working my way through and I kind of know what I'm doing. But if you're actually doing this as part of a team, where different members of the team are in charge of different parts of the system, if someone has to drop in and make huge changes to one of the fundamental classes, this could probably throw everybody else out, because they'd have to make sure they had updated copies and all kinds of weird and unpleasant stuff. So this kind of thing, really important. Those activity diagrams, if you've drawn them properly, you should be able to go through those and make sure that the activities can be underpinned by the data design that you've got in the classes that you've made. Otherwise, you'll do what I'm doing, which is find out that you've missed things out when you're trying to write the code. And this is a bad thing. I'm not particularly proud of the way I'm doing this, but I'm hoping you're finding it useful and maybe even educational too. So we'll keep moving forwards. This is the starting point of the method that will be called when a lendable item is returned to the shop. Okay, so this is the thing which will deal with reservations from the perspective of when somebody brings an item back. And so I've called it update reservation status, although I seem to have spelt it incorrectly. Sorry, it should say status. I do apologize. You can all have your money back. Oh, no, you can't. So the method that deals with reservations is given two things. It's given the Game Club, which is the club that contains everything. That's the big container. And it's given the item that's been brought back. So we get a barcode or a magic number off that which back, find the lendable item, that barcode, attach called return to shop, which is a returned item status value, because there's two things that can happen when we bring back a title. We can either return it to the shop, or we can put it reserved. And I've also seen I've put 2 semicolons on that. I wonder why that is. Think of trouble. I don't know. Keep moving forward. Right, so when you bring something back, if it's reserved, then we have to put it on the reserved shelf. If it's not reserved, we can put it back in the shop. So my little method returns one of 2 values: return to shop or place on reserved shelf. Okay, these are the 2 things. These are the 2 outcomes of the method. It either allocates it to a member who's reserved the thing, and that means we mustn't put it back out there for anybody to come along and pick up, or it says, okay, yeah, no one's reserved this, put it back out there for anybody to find. Okay, and I'm not bothering with any of that in the code that I'm writing just right now, because the UI, user interface code, will sort that out. It'll put a message box up or an instruction to the cashier or whatever you want to do. Doesn't matter. The control classes shouldn't talk to the user. They just return values which the code that talks to the user will deal with. So very important point this. The reason why I do that is because if I do it with this thing returning values, I can test against this. I can write my own unit tests against the behaviors of this method. And so if I've got this kind of action going on, then I'm going to just return a value, and then the code that calls my control class can use that value to do whatever it wants. And if I build some unit tests, they can make sure that if I call this thing and it tells me that it's supposed to go back in the shop and it's been reserved, some part of my system is broken. So can you see that? Well, you can't see anything because, well, you can see, but you can't see me. But I'm hoping you can see. That's better. I'm hoping you can see that my control classes just return information for whatever called them to use, but they don't talk to the user. Never do. Never should. Okay, so here you go. This is using the get reservations for title, which you've already just seen. The GameClub gives me this, so I can give the title of an item to this method, and it'll come back and give me a list of reservations. If the count of that list is 0, in other words, no reservations, just return straight away and say, okay, put it back in the shop. We don't care. So this is the simple path. Okay, no reservations, straight back in the shop, and the code just does this. Okay, so we get the reservations that are out there. If the count for these is 0, then we don't have to do anything. We can push it all back. Okay, now we have a bit of jiggery pokery, to use a technical we have to find the oldest reservation in town. Okay, there might be a list of these. And so if you're harking back to the dim and distant past when you were writing things like I think we're doing this with cricket scores or something, we're trying to, or exam values, there's a standard pattern where you have to find the oldest one or the biggest one or the highest one or the fastest one. It's a standard routine. And so what I'm doing here is pretty simple, I hope. I start off saying, okay, the first one I've seen is the oldest. And then I go through the list of all the reservations that we've got, and if, and I'm using this compare to method which is exposed by the date time object, if the one we're looking at is older than the oldest one, then I copy the time of the oldest one and the oldest reservation and use that to play off next time. So this is a standard technique. We're saying if I've just seen a new one that's older than the one I've already got, that's my new winner. This is a standard way of actually finding the biggest or the smallest or the whateverest. And so it just works by comparing these creation dates that we set up. So we do that, and now when we've finished my little for each, by the way, wonderful trick, takes me through a list of reservations, and it basically, each time round the loop, res is set to the next item in the list. So this will go round for each of the items in the list. Of course, if there's just one item in there, it'll go round once, do not a lot, and drop out. My oldest time and my oldest reservation will be the first ones in the list. If it's got more than that, it'll work its way through and find the one that matches. So that all makes perfect sense to me, and I hope it makes perfect sense to you as well, so we can move on. Right, so what I've done now is I've the story so far, okay? Jim has brought back a copy of Halo Reach that Robert has reserved, okay? So Jim hands it over to the cashier, and the cashier puts the system in, and it goes, hey ding a ding, this copy has been reserved by a member, and although 5 people have reserved it, the one who reserved it first was Rob. Okay, so now we have a physical copy of the disk that we want to give to Rob. Okay, so we have to update the reservation class to say, okay, we now have a physical copy of the disk that Rob is going to have. So the title reservation class must hold a reference to that physical copy. So when Rob comes in and says, hey up, I've come for my copy of Halo Reach, the system can go, okay, here it is, and hand you it off the shelf. Okay, snag is, of course, my class doesn't have that in at the moment, so here we go again. I have to add another item, another property to my title reservation class, which is the physical copy, the item that has now been reserved. Okay, initially it'll be null, because when I create the reservation, the reason why I'm reserving the thing is because there's no physical one available for use. So it seems to me quite sensible that we actually have to set it up as null, and then when we get one, we'll make it non-null. We'll set it to a value which indicates that, aha, we've now got a physical copy for Rob to use. Right? Done. I put this in red because it's really important. I've had to make another change to my business classes because I didn't go through the activity diagram and make sure my class design could support this. If I'd read the activities, I would have figured out, oh, I need to keep track of a physical copy with each reservation as well. But I didn't do that. I started coding. Very, very bad. Slap on wrist. Ow, that hurt. Okay. While it's true that this will tend to happen, whatever you do, you end up having to refactor code and move things around. It's important you try and keep this to a minimum. Otherwise, you go nutso. And if you're working in a team, they go nuts as well. You should have such a good understanding of your class design before you write the code that you shouldn't be doing what I'm doing. But I'm kind of exaggerating or something to sort of make a point. That's my defense anyway, and I'm going to stick with that. So here we go. The oldest reservation I've found, set the reserve item to the item we've had returned, and then return I'm sorry about the word return here, keeps appearing. I then send a message back to the person that controlled the control class, saying, hey, tell the cashier to put this on the reserved shelf, not out for anybody to borrow. And so this effectively makes a copy so that we know which particular physical item Rob has been allocated, and then we say, oh, and by the way, don't put it on the main shelf, put it on the reserved items shelf. Okay, that's how it works. Unfortunately, it's buggy. You won't find it's buggy until stuff starts going horribly wrong and your reserved items shelf suddenly becomes full of stuff that nobody seems to want. The reason for this is that the oldest reservation gets each returned lendable instance assigned to it. So if the second person brings back a copy of Halo Reach, that'll get assigned to Rob as well, because Rob's the oldest one, and nothing in my program checks to see if Rob's got his copy assigned to him. So how do we fix this? Well, at this point I was going to do a show of hands and have a really good discussion about how to make it work, but that's not going to really work terribly well here, so I'm going to have to just dive in and tell you how I would fix it. We asked the GameClub for reservations for a title, and it should only return active ones. In other words, we asked the GameClub, how many reservations have you got for this title? And the GameClub should only return ones that are active, i.e. ones which have not got a lendable instance available. Okay, so I don't care at this point about satisfied reservations because they're okay, they've got their copies. And so to do that, I'm going to dive into my code and change the method to actually make it only return methods that are satisfied. And remember that talk about dependency and cohesion and stuff? I have to make sure that anybody else that uses this thing is actually aware of the fact I've changed this. And so what I tended to do at this point is change the name of the method. In fact, having thought about this properly, I might just make a brand new method that only returns unsatisfied reservations and call that one instead. Okay? Either way, I have to sort it out. I've called it get unsatisfied reservations for title, and now it has a test in the middle. If the reserved item for this reservation isn't null, continue. just go round again. So yeah, I think having thought about this properly, I'd make a brand new method with a new name and use that rather than start fiddling around with existing code, because otherwise I might break something somebody else is doing. So keep all that in mind, folks. This is all good, clever, proper common sense. So this will make sure that when the second copy of Halo Reach gets brought back, it isn't assigned to Rob because he's got his. The next person in the list gets it this time, and it goes through and through and through. Okay, so a little bit more implementation fun and games. Ideally, if I'd thought about this properly, I'd probably have made the title reservation class stateful. I haven't got an item assigned. I've got an item assigned. The member has been contacted to say, hey Rob, your copy of Halo Reach has arrived. The reservation has been collected, or Rob didn't come in and get his copy of the game, so we expire the reservation and let somebody else have it. Okay? This would actually really help our reservation system. It would really make it very easy and clear precisely what's happening at any point. And again, bottom bullet point again, the earlier in the design process we make these kind of decisions, the absolute better. So thinking, maybe a state would be a good idea now, means I have to go back, and you're going to get another one of these sort of, please make sure you go through your activities before you write your code. So what have we learned? Well, hopefully we've learned that a good understanding of the problem is an absolute must before you write the code. Okay, you're gonna hit problems anyway, so you don't want to spend if you aspire to perfection in your data design before you write the code, then you're going to come unstuck. It ain't going to work. In all my experience, I've still had to do the kind of tweakage that we've been doing all the way through this, and it's just one of those things. The Americans have the phrase "suck it up," which doesn't sound very nice actually, but basically what that means is just take this on board, mate, and deal with it, because otherwise you're going to be a very unhappy person. You will have to change the design of your framework as you implement it. That's one of these things that you can't, no amount of prep will remove that need. But you should still try and make sure that your design is as solid as possible before moving to implementation. And getting a bunch of people round, working through the activities, drawing out the classes as you go, and making sure that all your links, associations and properties are in place is a brilliant way to do it. Whenever I've worked on this kind of thing with more than one person, I've found it's incredibly valuable. Having one bloke do the design and then present it to the rest of the people as a done deal doesn't always pay off. If the whole bunch of you argue and talk through, and people ask daft questions like, how does a reservation know which physical copy has been assigned to it? If someone asked that question at the start of this, my diagram would have been much more sensible, and I'd have less rework to do. So please try and make sure that your design is as solid as you possibly can get before you start making it work. Okay, so what I hope you've pulled out of this little session is that effectively we write a method which runs through the activity in the activity diagram, or at least those behaviors that the system is required to deliver, and that this is a freestanding piece of code that isn't part of any particular business object, although we will call methods on the objects to do stuff. And as we go through, we'll probably find as we write the method we have to add behaviors and data to our business objects in order to get things to work. So don't say that when you do that you have to you've failed, because you haven't. It's just that your code has got closer and closer to what it's supposed to do. But I found that particularly getting the activity diagrams nailed against the class design is a really good and important step. The CRC cards that I mentioned earlier, class responsibility collaboration, they're another good way of making sure that your diagram fits the activity, and so by all means have a crack with those as well. And I reckon that's the end. If you've got any questions, you at the back, you're not here, I can't see you, so no answers for you, I'm afraid. Right, business as usual next week, hopefully with a bit less snow.